All right, folks. We are hopefully did some work on a worksheet today. Then we had introductions and how we're going to come in and out of the room and all that stuff, and how we're going to clean our areas. And so I don't know how many problems you got through. I'm guessing hopefully you got through 20, 25, maybe more. I don't know the rate you're working at yet till I get a chance to see it. So I thought I would make a video of the second half of the worksheet. Um, and I'm sure in class I'll tell you, look at the ones you think you need the most help with. I hope everybody looks at problem 23, which is the first one I'm going to do right now, and then I'll go from there at the beginning of the year. I'm sure probably don't remember because it was only said once, but one of the goals of this class is I'm hoping that you can appreciate at the end of the semester what I call the art of symbolic conversion. And this is a perfect example of that. Of you've got the marker in your hand. If you don't have what you want, you got the marker, you get to write something that makes it happen. So here we go. We had roots at 5, -3, and 0, which at 0 means that x is a factor, part of the multiplier. -3 means that x plus 3 is as well. And 5, x minus 5, all factors of a calculation. So what have I created? I've created a cubic model. And in this cubic model, I want a 1 to give me -23. Okay, I've already made sure that if I put a 5 in, I get a 0. If I put a -3, I get a 0. If I put a 0 in, I get a 0. Now I've got the marker. I get to look at what happens when I put a 1 in. When I put a 1 in, I get 1 times 4 times -4, which is -16. I don't want -16. So I'm going to get rid of it. I want -23. Obviously, you can doctor that up and get rid of the minus signs. That works for all of those. So it's a unique graph. Now I asked you to look at inequalities, so from a graphical position. So these are all the first power, So therefore, I know I have a linear, well, first off, let's see what happens. End behavior, put a billion in. Billion positive, billion positive, billion positive, positive coefficient. It's going up. So I have a linear root at 5, a linear root at -3, and a linear root at 0. So therefore, my graph looks like this. Okay, something like that shape. And does a 1 get me -23? Yeah, I think it looks pretty good. Looks pretty good. Now, I just decided to do a little work with it to bring out another concept that we've been talking about. So if you multiply x times x plus 3, you get x squared plus 3x. I'll do it up here. You get x squared plus 3x. And if you multiply that times x minus 5, and then if you multiply that times 23/16, you get what's here. So can you spot the y-intercept if it's not written? There's a constant here. Well, I hope so. And what does this tell us? The linear term tells us that at the origin, we're going down about 20-1. And it tells you the same information as what you can infer from the quadratic, right? Because if I put 0.0001 in, boy, it's like exponential decay, exponential decay. This is where you're going to get change. You're not going to get it from the constant column. All right, so I just wanted to make a few comments on 23 because I think it's a beautiful conversion. It's just such a simple thing, but the simplest things in math oftentimes go woof, woof, woof. I thought that was ridiculous looking, so I did it another time. Okay, 24. Gotta have a little fun here. 24. X squared plus 10x minus 4 equals 0. X squared plus 10x minus 4 equals 0. Yeah, we're in trouble. You can't factor that critter. I suppose we could find the vertex, and we know the a terms are 1, and we could do that little trick we're doing with quadratics. But I think when you see x squared plus 10x, I'm hoping that you can tell a little more quickly that if we did that, we'd get those first two terms because we started with some binomial squaring, pushed it heavily. There was a reason for that. This is the reason. Okay, the only problem here is if you do square this, you get x squared plus 10x plus 25. Does anybody see positive 25 up there? No, but I got the marker. It's now gone. And now I've created those first two terms. Why don't we move the 4 to the other side? I think I can isolate this pretty quickly. So x plus 5 squared equals 29. So therefore, let's cut to the chase. X equals minus 5 plus or minus the square root of 29. Square root of 29 is between 5 and 6 units. So somewhere to the left of the origin, I should have myself a little intersection and near the number 10. Okay, so what else could you have done? Yeah, we could have said that it's cup shape up. We could have said that I'm on the upside going up at 0, right? I could have done this, and then I know that this is negative, right? So this is got to be a negative number. So 1 into 10 is 10, cut in half is negative 5. And if I put negative 5 into here, I get minus 25 after I cut it in half, and that gives me negative 29. So how am I going to get back up to a height of 0, which is here somewhere? There's my origin. How am I going to get there? Oh, I should have put it. Well, that was the y-intercept, right? So I'm butchering this thing. All right. So how do I get up from 5, negative 29 to a height of 0? Well, that's why that's got to be positive. All right. And then we're going to divide by the a term, which was 1. And negative 5 is going to become what? Positive 5. I guess we're done. Oh, plus minus, excuse me. Should have done plus minus. Oh, wow. And we saw those numbers materialize when we did x, what was it, plus 5? X plus 5. I might have made a mistake there. I might have said positive 5 instead of negative. I don't remember. Okay, but we got to x plus 5 squared equals 29. Negative 29, right? What was it? Positive 29, yeah. All right, and that was the first thing that showed up in the square root, right? And then what do? You divide by a. Well, a was 1 in this case. And what do you do with squaring? Plus minus square rooting. And positive 5 becomes negative 5. I hope I didn't say positive 5 before. I think I did. Okay, I might have made a sign error there. Okay. I find that the older I get, the more that happens. Vernon, I'm coming. Okay. 8x cubed minus 27y cubed. I'm guessing. It's on our curriculum, Algebra 2. You're supposed to know the difference of two cubes, how to write it as a product. I doubt you remember. I don't know. I got 2 or 3 students I had last year. I'll ask them if they remembered. We did practice it, hopefully enough. But there's a pattern here. So let me show you the pattern with a couple of easier numbers. Let's try 125, and we'll do a plus this time. 125 plus 27. We know that answer is what? 152. Well, the same way that Greeks get credit for working with squares, we're going to work with cubes, and we're going to work with the cube roots. So we got a cube here, and what's the volume of the cube? 125, and another one over here, cube, boom, 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 right there, 27. And so what do we have? The dimensions of those cubes. This is a 5 v5 v5. This is a 3 v3 v3, and we're going to work with these two numbers. First thing we're going to do is add them. Why are we adding them? That's why. Then we're going to figure out what the pattern is here. The drawings to this are probably pretty complicated, but I'm sure they're probably somewhere floating around in Google. They got this new thing called Google. Yeah. So this is a 1 dimension. We got to get the other 2 dimensions, right? Because it's a 3-dimensional shape. So step 1, square the first term. We got to get cancellation here because I'm going to have 6 terms. If I do, well, I'll get ahead of myself. 5 times 3 is 15. Do the opposite of it, minus 15. And 3 squared is 9. Okay, so that's 8 times 19. 8 times 19. 8 times 9, there's your 2. Carry your 7, there's your 15. So it's the same amount. It is the same amount. But let's show you why. So 5 times 25 is 125. 5 times minus 15 is minus 75. 5 times 9 is 45. 3 times 25 is positive 75. 3 times minus 15 is minus 45. And 3 times 9 is 27. Looks like I got 125 plus 27 because these are canceling. Okay, so there's a pattern to this. You want to be able to factor the difference or sum of two cubes, you got to put the effort in to learn the pattern. Once you do, you get one of these from me. Okay, there's really nothing to figure out here other than memorizing a pattern. So let's do this one and start doing one every day. And if we do it every day, we can get it down to 5-10 seconds a problem, and we'll put it in long-term memory. So what's the cube root of 8x cubed? 2x. What's the cube root of 27y cubed? 3y. So in this case, it's 2x minus 3 because we're doing a subtraction problem. What do I do with the first term? I square it. How do I get the second term? It's this product. And that product is minus 6x. Oh, I forgot the y here, sorry. No, I'm having a tough day. There we go. So how do I get the next term? Product, got to square it, right? 2x times 4x squared is 8x cubed. How do I get cancellation? The next term is opposite this. And what is it? It's the product, minus 6xy. So I'm going to say positive 6xy. It's kind of like a conjugate. Gets rid of some things. It's not a conjugate, but it's kind of like it. And how do I get the last term? It's always positive, right? If you square that, you're always going to get a positive, 9y squared. Now, if you want to prove to yourself, do the foiling, get a column underneath it in the right like terms column. You'll see the 4 terms cancel, and you'll be left with 8x cubed minus 27y cubed. Okay? All right, be interesting during the workshop. If I see my former students get to that problem, I'm going to be eagle-eyed. Let's see if they remember it. They don't. I'm going to do it more in this class. All right, next question. 2x squared plus 8x equals 10. 2x squared plus 8x equals 10. Something like this, you should divide by 2 immediately. And 4x equals 5. Oh, 1 times 5 is 4, so we got a factoring problem. Well, why belittle it? Why look at anything right now other than just a quick bumpity equals bumpity. And so we got an x and a 1 and a 5. We want it positive, so that's the positive, that's the negative, and you have answers of negative 5 and 1. Okay, negative 5 and 1. And if I wanted to graph 2x squared plus 8x, I would start at the origin. That's the y-intercept. I'm going up at 8, and it's cup shape up. And where's a height of 10? Over here. When x is 1, I'm at a height of 10. And what's over here? I think it was negative 5, a height of 10. Right, that makes sense because you can see negative 4 and 0 as roots. Right, put negative 4 in and 0. Right, take out what's common, 2x times what? X plus 4. So you can see negative 4 and 0. So the graph matches up for a height of 10. All right. Now we got 3x squared plus 5x minus 8. So I got choices of 1 and 8 and 2 and 4 over here, but there's one thing that has to be true if it's factorable. If I can write it as a product, 3x times x has to get me 3x squared. Now these numbers I am going to try here because that product's going to have 3 times the influence than this one is. So I'm looking, and I'm going, whoa is me. Whoa, I see 8 and 1. I see 8 and 1. I see 8 and 1. There's 3 and 8. I want that to be positive. I'll make that positive, that negative. So all I did was throw numbers in, right? I tried 4, 12, and 2 doesn't match up. And that's what you should be practicing, like a computer. Boo, 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 with clues. All right. Boy, I'm already pretty silly, and it's the start of the worksheet. Got to help us when I get to number 47. Minus 2 plus the square root of negative 40 over 2, minus 10 plus the square root of negative 40 over 2. I should start labeling what numbers I'm on. This is, I believe, 28. And what I want to make sure everybody knows is you would never do something like 5 plus 6 is 11 divided by 5 is 6. That's a common mistake. Okay? This is the same thing. 5 plus 6 divided by 5 is the same thing as saying 5 plus 6 times 1/5. You know you do it to both, right? So you got to divide this into both. All right. So there's -5. And now we're going to add some kind of square root of 40 over 2 that is imaginary. Okay, so what is the square root of 40? -5 plus the square root of 4 times the square root of 10, I divided by 2. And now we can see that that cancels. There's our answer. Okay? Right. Could go backwards from there to find the original equation pretty easily, actually. So now here's another one. This is new. I think it's very, very useful. It will help you solve. I'm going to put x cubed minus 6x squared plus 7x minus 1 down here. Okay. We're trying to get a product that equals that. The reason I show this is I think it's good historically. This thought process precedes long division, which precedes synthetic division. And before computers, folks used this technique to evaluate functions at given x values. Okay, and with enough practice, you can start to see that historical development. I got the marker, I get to write what works. If I multiply x times x squared, I get x cubed. I'm on my way to a correct answer. Right now, these problems are going to go from 2 to x to the 1 to x to the 0 with a remainder. So I know my next one is going to be something to do with x to the 1. And that just needs, right now I've got -5x squared. Right now I got the number -5. How do I get from -5 to -6? I got to go down 1. I got to go down 1. Okay? Students notoriously have 2 or 3 days of difficulty getting the hang of this. All right? And sometimes we even do 3 or 4 in a row. But within 2 or 3 weeks, most everybody's getting it right. So cheer up. All right, so right now I've got -5 times -x is positive 5x squared. And right here I've got -x times x is -x squared. Oh, this is -5x squared, I said the wrong thing. And -x times x is -x squared. What's -5x squared minus x squared? Okay, I got the next term. Get the marker. Okay, but now I've got to get to I got to get to 7x, right? I got to get to 7x, and I've got +5, right? I'm at negative times negative. I'm at +5. How do I get from +5 to -1? Wow, I don't know. How do I get from +5? From +5, +5x. Oh, so I'm sorry, to 7x. How do I get from +5x to 7x? I add 2. All right, there's my 2x right there. And add those two. And 5x plus 2x is 7x. But now I'm at -5 times 2. I'm at -10. I'm at -10. How do I get from -10 to -1? I got to go up 9. Okay? Now, because I paused and talked about this, I hope I didn't get lost in the minutia, right? Because it's really a straightforward process where you're just looking at the numbers and writing your answer. But if I were to put 5 into this right now, this is a function. I've written this function in a different way. Okay, but hopefully you can tell me what f of 5 is. So you look at it for a second and tell me what f of 5 is. Okay, and then if I made a mistake here, that happens in math, then I'm not going to talk. I'm going to go back and do the problem again and just concentrate on it. Okay, f of 5. Well, 5 minus 5 is 0. 0 times anything is 0. Sure looks like it's a 9. If this is the same calculation, then when I do 5 in here, what's f of 5? Let's find out. 125 minus, let's see, 6 quarters is 150, right? And 7 times 5 is 35, minus 1. Okay, so let's go. 125 and 35 is 160. Minus 150 is 10. 10 minus 1 is 9. Okay, so I didn't get lost. And what's helpful is learning how to write this so that it's inside the parentheses. And hopefully you can see that When I do the last multiplication, the x minus 5's cancel, and I add 9 to the negative 10. All right, so that was a little awkward in terms of having to talk about it, but hopefully we're going to start practicing those, and when somebody in your group gets it right, I'll give you another one. Here, I'll do a quick quadratic with you since it's such a new skill. So let's look at x plus 2 times what equals x squared minus 5x plus 10, okay, which is not factorable. So what do I have to multiply x by to get? I got to do x. Right now I got 2x. I want to get to minus 5, so minus 7. All right, that gets us the first two terms, but 2 times minus 7 is minus 14. How do I get from minus 14 to 10? I got to go up 24 units. I got to go up 24 units over x plus 2. Okay, now if these things are equal, if these calculations are equal, then when I put a negative 2 in, I should get 24. So negative 2 squared is 4. Minus 2 times minus 5 is plus 10. And another 10, I made a boo-boo, not negative. Negative 2 squared is positive 4. There's your 24. Okay, so I did it from two different directions. It matches up. That's correct. All right, so remember, that takes a little practice. But here's what people can't do in a calculus class. People can't do x squared plus 2x minus 8 all over x plus 3 dx. All right? The calculus part of that, once that's simplified, everybody can do because we study it and it's not hard. But folks don't know that, oh, you could have written this as x. I want 2. I'm right now at 3, so I got to go down 1. Minus 1 times 3 is negative 3. I got to get to negative 8. So if I got to get negative 3 to negative 8, I got to go down 5 over x plus 3. And everybody in the calc class after a few days could do this, what operation is being asked, which you have no clue about. But that's what gets people bad answers, okay? I'll take more time with it and see if you can practice this. I hope I don't exceed my time limit. So we got x squared plus 2x minus 8. All right, so everybody can get that. Right now I'm at the number 3. I got to be at 2, so I got to go down 1. Right now I'm at the number negative 3. I got to get to negative 8. How do I get from negative 3 to negative 8? Minus 5 over x plus 3. What's the critical number? Negative 3. Negative 3 squared is 9. 2 times negative 3 is negative 6. Minus 8 is 9 minus 14. What is 9 minus 14? Negative 5. It checks. Okay? All right, so just giving you a heads up as to where you use that skill. Okay, minus x squared. Minus x squared. And if you've looked at the inequality video before you go back to these problems, you might have a crack at this. X plus 5 squared times x minus 6 less than or equal to 0. So x-axis, going to graph it. I've got an even exponent, so at 0, I have no sign change. At negative 5, I have no sign change. And at positive 6, I have a linear sign change. All right? All right. Let's put a number in. Bigger than 6, a billion. Minus a billion squared is a negative number. Minus a billion squared, well, that's always going to be positive because the coefficient's inside the parentheses where it's not over here, right? Bigger than 6, that's positive. So what direction is this polynomial heading as I go to infinity? What is the limit as x goes to infinity, which is why I picked a billion, of this function? Well, it's going down to negative infinity. And it's a linear cut, a quadratic, so it's a linear factor, a quadratic, and another quadratic. That's what this graph looked like. What am I, less than or equal to 0? I'm equal to 0 at negative 5, also at 0, also from 6 to negative infinity, excuse me. No, 6 on x values. 6 to infinity, and you can't bracket infinity. It's not bounded. Okay, that's that problem. All right. I'll probably have to put this on my YouTube channel and then upload it to you folks because I'm talking a long time here. So x minus 5, did I That was 30, problem 30, huh? 31, I think, was x1, y1, x2, y2, and I think it was square root. All right, so I want it to go through x1, y1 with a square root. Well, that's not hard. X minus x1 plus y1, for those of you who like formulas. Okay, I'm getting rid of this number. Whatever it is, I got rid of it, and I brought in what I needed. This is not inside the square root. Let me put that a little lower right there. Okay, so that's a subscript 1, subscript 1. All right, now what happens when I put in x2? x2, oh, geez, I don't want the square root of that. Probably don't want it. Right? Whatever it is, I got to convert it into y2. Well, y1's in the way. Got to get rid of that too now. Boy, that numerator should look a little more familiar. I hope that means a little bit more to you right now than it did 20 seconds ago. Right? There's a two-step conversion here. I got to convert the change, and I got to get rid of the first y. Hence, y2 minus y1. So, if I said, what is it, 5, 2 through 11, 20? All right, well, you do x minus 5 plus 2. What would you do here? You do 20 minus 2, right? Because you got to get rid of that 2, and you'd have to get rid of square root of 11 minus 5. That's what we did a second ago. All right. And if you want to see the mechanics or the numerical mechanics of it and really understand it, you're going to have to keep looking at it all semester. All right, A equals PE to the RT, another problem you should have done last year. All right, this is compound interest. That's the principal. That's not the head of a school, public school. No, that's the principal. That's the amount of money you throw in the bank. This is the interest rate. We know what E is. And I might as well show you where E came from because somebody asked. X goes to infinity of 1 plus 1 over x to the x. Okay, so if I put the number 1 in, I get 2 to the 1, which is 2 for this calculation. If I put a 2 in, I get 3 halves squared. 3 halves squared is 9/4. If I put a 3 in, I get 4/3 cubed. 4/3 cubed is 64 over 9. No, I did some 64 over 27, sorry. Now, I don't know what that is as a decimal. Throw it in. I know this is, 2.25. This is 2. This is probably around 2.4, I'm guessing. I don't know, but guess what number we're headed towards? 2.71. If you keep doing that forever, you get E. And what E is all about an exponential function whose rate of change is the same as the amount and whose acceleration is the same as the rate. Now, what the heck does that mean? That means at 1, E is approximately 2.71. Not only is the amount, but the rate at which I'm changing. The rate at which I'm changing is also 2.71. Not only is the rate, but the acceleration is 2.71. Now that's a very useful calculation, especially if you don't have computers and calculators. And people way back when doing math didn't. So this calculation gives you information, lots of it, about stuff in the real world. Okay? All right. Boy, I'm giving a lecture. 28. What the heck was I after? Oh, A equals PE to the RT. A equals PE to the RT. I want to know how long it doubles at a, oh God, I don't have the rate in front of me. I'm not going to go looking for it. I'm going to say a 5% interest rate. Yours might be different. If it's a 5% interest rate, then up here I do 0.05 T. Okay? And I don't care how much money you start with. If you're going to double it, whatever that amount is, this is going to be twice it. Right? So if I add $100, this would be 200. So what's the first thing we do? We divide by P. 2 equals E to the 0.05 T. Okay? And I want to know how long it takes to double. Okay? How long does it take to double? What's the next thing I'm going to do? The inverse of E. We got a mantra for that, right? E to the inverse is ln of. So this is the ln of 2 equals 0.05 t. What's the next thing I'm going to do? I'm going to divide by point. Can I change this to 0.7 now? It's an approximation now. This is not going to be an exact answer. Approximation. Let's get the exact answer. The ln of 2 divided by 0.05 is t. Now we'll approximate. Okay, I think I'll put this down a little bit. There we go. So 0.7 divided by 0.05. All right, if I multiply everything by 100, get rid of the decimal. So that is equal to 70/5. Wow, it takes 14 years to double at 5%. Money gets doubled in 14 years at 5% compounding interest. Now let's take a look at our answer. Okay, and let's say you had $300 and you want it to become $600. How long does it take to double at 5%? There's our answer. How long does it take to double at 5%? I wonder if there's a little pattern here. Next problem. 12, square root of 12x y to the 14th z to the 31, which is the same thing as saying 12x y to the 14th z to the 31 raised to the 1/2. Well, I hope we can see that exponents are no problem here, right? You're really just 14 divided by 2, 31 divided by 2 with a remainder, right? So what are we going to do? Up here, we've got to deal with the square root of 12. All right, square root of 12 is the square root of 4 times the square root of 3, right? And I know that I have, let's just do it out. So this is 2 times the square root of 3. That deals with the 12. Not enough. If I divide that by 2, 7 of them come out. If I divide that by 2, 15 of them come out, but there's 1 remaining inside. Okay? Theoretically, this is just review from last year. If it's new and you haven't done it, we'll get you up to speed. All right? The next one is a cube root, and we do the same thought process. Cube root of 16. The cube root of 16, which is 8 times 2, that's 16. And then we've got x21, y8, z1. x21, y8, and z to the first power, I believe. Maybe I forgot to write something. I don't know. We know what the cube root of 8 is. It's 2. Where people make a mistake is they just do that quickly, but it's not a square root. It's a cube root. You got to remember to show that to the reader. Okay? Oh, 3 goes into 21, 7, that's, the same thing as something, cube root is the same thing as doing that, right? Okay, so we're dividing by 3. 3 goes into 8 twice, and then there's remainder of 2. Oh, there was a 2 here, right? What did I take? I took the 8 out, there's still a 2 there. Okay, and this was still there, forgot to write it. And now I've got to deal with z, well, I can't take that out. And if there's another number there, I forgot to write it. All right, next problem. That's just pure mechanics, foundational stuff. 12 over a minus a equals 9 over 2. Well, the old guy's getting tired here. So I'm going to multiply by 2a. I'll put a comma here. All right, these are the dividers that I do not like in the problem. I don't like them. I'll get rid of them. What gets rid of division? Multiplication. What cancels here? The a's. So that's 24. Nothing cancels here. So that's minus 2a squared. The 2's cancel, and I get 9a. Oh, I hope I didn't just make something up at random because I don't feel like factoring this. 0 equals 2a squared plus 9a minus 24. Let's see. So is this factorable? 2a, well, this is where the quadratic formula comes in handy. This part of the quadratic formula, tells us that if we have a nice square root, I think it would be faster than doing it. Well, the heck, we could do cup shape up. We could do it. 9a's on this side, so minus 24 is on the increasing side. So I'm going up at 9 to 1, so I now know that, yeah, it's fractional. I know that this is going to be a negative number, and it's negative 9/4. This becomes a pain. All right, so let me see if it's factorable. If it's not factorable, I apologize for giving you something that would slow us down so much in class. All right, so let's just see if it's factorable. All right, so I got 24, which is 1 and 24, 2 and 12, 3 and 8, and 4 and 6. I got a lot of things to consider here. All right, let me see if I can spot something quickly. 24 times, I don't like that. 12 times 2, 24, and 2, I don't like that. 8 times 2, 16, and 3, I don't like that. 12 and 4, I don't like that. 8 and 6, I don't like that. 6 and 8, I don't like that. 4 and I don't like that. I don't like any of them. So I don't think it's factorable, which means that it's a pain in the tail problem, which means I don't want to do it right now. It's my class. There we go. You'd have to do that process with fractions, and I haven't had you practice that yet. Especially when we're going to start doing fractions, I'm going to give you the number 1/2 first. All right, and then maybe a 4th, and then we'll get to something like that. All right. Number am I on? 36. So the square root of 2x plus 4, okay, which looks like negative 2 is the critical number. So I'll give you a quick sketch of that. Negative 2, 0. This goes through negative 2, 0, and it's a positive square root, so it's climbing slowly. And we want to know when that intersects with x minus 2. X minus 2, let's call that minus 2, probably a little lower, going up at 1 to 1. So there's one answer here. All right, there's one answer, but we're going to be squaring, which means we might get an extra answer called, in math, an extraneous root. We might get an extraneous root here. Yeah, plenty of power there. All right, because the inverse of one of these is really one of these. It's got a lower branch, but that's not a function. And another reason you could get an extra answer is x equals 3. If we square both sides, we get x squared equals 9. If we solve that, we get plus or minus 3. Well, how many work in the original? Just one. So you got to get in the habit of checking your answers here. Make sure that you don't give me that extra answer that's not real. Okay? So step 1, square. 2x plus 4 equals x squared minus 4x plus 4. I hope folks are not forgetting that term. All right, so what's the next step? Set it to 0. Set it to 0. So we got x squared minus 4x, bring the 4 over. They cancel. Oh, that's nice. These cancel. And so I'm subtracting another 2x. So x squared minus 6x equals 0. We can see our answers here, 0 and 6. Okay, so what we had was this, 0. 0 would have been the fictitious answer here, and this is intersecting at 6. What do you get when you put a 6 in? 4. What do you get when you put a 6 in? Square root of 16, 4. Okay, so that's the point of intersection. Just 6. 0 is fictitious. Extraneous, excuse me. Gotta say the right word. Oh, God, extraneous roots. Square root of 8 to the 60th is the same thing as saying 8 to the 1/2 to the 60th. And I hope everybody can see why that is 8 to the 30th, right? Square root of a times the square root of a is a. So 2 gets you 1. That was quick and easy. 4 times, if you looked at the inequality video, this won't be so bad. I'm looking at greater than 41. So I know I got a V shape. Greater than 41 is going to be an interval on the right and an interval on the left, because this is cup shape up. Vertex at 4, 9. All right, but let's just find the numbers, put them on a number line, and do it the way we talked about in the video. So I'm going to take a shortcut here because I'm getting tired. I'm going to do 4 times 2x minus 8 plus 9, and I'm going to set that equal to 41. So subtract 9 gets me 32. Dividing by 4 gets me 8. 2x minus 8 equals 8. Adding 8 gets me 16. And dividing by 2 gets me 8. Wow, a lot of 8s in that problem. So that's one of the roots. So 2 times 8, 16 minus 8, 8, absolute value of 8, 8 times 4, 32 plus 9, 41. I know this is centered at 4. I know it's centered at 4. So this has to be 4 less than 4. So the other root is 0, right? And I'll just cover that in. So now I'm going to look for some numbers that are bigger than 8 billion. If I put a billion in here, I think we can see that that's greater than 41. So that's true, that's false, that's true. So I've got negative infinity to 0. It doesn't say equal, so it's not a bracket. Union 8 to infinity. Again, I hope this is all review. All right, now to find that 0, you could have done -4, right? And then solve that. You would have got the 0. That would have been the decreasing branch. All right. Wow, it's taking a lot longer than I thought. 3 ln of x plus 5. I'm just going to do them out. I'm tired of talking. I'm sure you're tired of listening. All right, so just to solve this real quick, that equals 1. That equals a third. The inverse of ln is e to the, see, this is so dyslexic. I probably wanted the ln of a third because you could process that. This is actually the cube root of 2.71. I got no feel for that. I know it's less than 2, and I know it's more than 1. Okay, that's what you do with that. All right, I hope I didn't confuse you. The ln of 1/3, I want you to know. E to the 1/3, no. Log base 4 of 1 over 32. All right, so this is all about looking for exponents on top of a 4 that gets us 1 over 32. Problem with this is it's not the same base, but we could call 4 2 to the 2. Okay, so that becomes 2 to the 2x equals 32. 2 to the 5 is 32. So 1 over 32 is 2 to the -5. So we can see our answer now is -5/2. That means if I take the square root of this and then raise it to the 5th power and reciprocate it, I should get that, and you will. All right, 125 to the -1/3. I'll take the reciprocal last, but I'll take the cube root right now. That's 5 to the -1, that's 1/5. Okay, I don't know if it was to the 2/3 or hopefully I copied it right. ln of 16. All right, so I want you to practice organically getting these answers, and then we're going to morph it into our rules of logarithms. So right now, 16 is 2 to the 4th is the number 16. And I know 2 is e to the 0.7, approximately, to the 4th power equals 16. So what's the exponent that I put on top of 2.71? What do I put on top of 2.71 to get me near 16? Looks like it's 2.8. Looks like it's 2.8. All right. Are we done? I think we might be done. Oh my goodness. All right, if we're not done, I think there's 47. Oh, there's 47. That's right, it's up at the top there. Woo! Okay, so 45. I might be missing 44, but what I have on the tableau over there, it's not a tabula rasa, is x squared plus 12x plus y squared minus 14y equals -4. I'm hoping that this is review. So, we're trying to get Pythagoras here. A squared plus b squared equals c squared. A, b, and c. A, b, and c. And as a gets bigger, b gets smaller. As a gets bigger, b gets smaller. And we get this rotation. It's going to be very important when we get into trig. Okay? And what is Pythagoras all about? Pythagoras is all about the square areas. It's the square areas. So, if that's the hand of the clock, we've got to find that hypotenuse. Okay? So that's the square areas. Well, x squared plus 12x isn't a square. That's not a square, but I can certainly start to make it one. Right? That gets me the first two terms, and we talked about this earlier. Also gets me 36, which I don't see floating around up there, so I'll get rid of it. I know what that is. That's y minus 7. That gets me the first two terms, but I don't see 49 around there, so I'll get rid of it. -4. Okay, so now I'm going to bring the 36 minus 49. That becomes -85. Positive 85 on that side. -4 is 81. So if you doctor this up, you get this. All right, that's what you get, which matches up with this. These are the square areas. Those are the square areas. So what's your radius? 9. What's your new origin? Your new origin is -6, +7. I'll talk more about that in class. Okay, so looking at this, what's the center? The center is -6, 7. What's the radius? 9, because these are area statements. Okay, all right, next problem. Almost done. Almost done. All right. Log base 5 of x plus 4. Oh God, I can't even read my own writing. See if I can put some weight on that right leg. Oh, plus x. Okay, so I got it. Log base 5 of x plus 4. Oh God. Log base 5 of x equals 6. No, where the hell am I? Equals 1. All right. The last problem, I wasn't anticipating this, but these are all archived homeworks. ln of 16 was equal to 16. I'm going to do it this way. The ln of 2 plus the ln of 8. There's one of your rules. ln of 2 is 0.7. 8 is equal to 2 to the 3. 2 to the 3 is e to the 0.7 to the 3. E to the 0.7. 0.7 times 3 is 2.1. That's another way we could have gotten. The answer in a previous problem. So what's one of the rules? When you add exponents, you're multiplying the quantities involved. Okay, it's not a good explanation right now because I wasn't anticipating doing this soon. But if that's a rule, then that's a product. So that becomes log base 5 of x squared. I'll try to explain this better as we go along. Equals 1. Okay, but we are at the stage as to how to rewrite that. How do you rewrite logarithms? Exponentially. So the quantity x squared plus 4x is equal to 5 to the 1. Okay, so then we're back to a problem we did earlier. 4x minus 5 equals 0. And we had answers of -5 and +1. Okay, you can't put a negative in the parentheses. We've talked about that in class. So that's an extraneous solution. I can put a 1 in. 1 plus 4 is 5. 5 to get a 5 is a 1. And if I put a 1 in here, anything, 0 on top of anything gets you 1. So that disappears and 1 equals 1. So it does check mechanically. Okay? Oh, Lord. Y'all guys really flaming out here. All right, the reason I put this on here, cosine of -19 pi over 3, is I've had some students in my topics and trig class, and I've had students in the algebra 2 level. And whenever I teach those classes, I always teach the unit circle so that kids get off to a good start in their pre-calc classes. A lot of people flame out on this. So I wanted it done the year before. All right, I've got a unit circle introductory video that I'm going to have you watch Friday night. I'm going to replay that, not replay it, I'm going to recreate it in class. And usually speaking, about a half an hour after people start practicing this, they start, half the class starts doing pretty well. All right, so this is just a review to get the kids I've had before, the students I've had before. And the reason I'm doing that, I'm creating tutors in the room so that if a group is working on this and it gets stuck, I can point to somebody who I know knows how to do it, go help. Okay? All right, so pi, we just started talking about it in one class, I don't remember which, 180 degrees, right? 2 pi r is circumference of a circle, right? And if the radius is 1, then pi is 180 degrees. I'm going to break it up into 3 parts, 3 equal parts. And now I'm thinking about this as the x-axis, this going up there as the y-axis, right? I'm in the xy coordinate system. So I am at -19 pi over 3. So that's 1 pi over 3. That's 2 pi over 3. And that's 3 pi over 3. Which means that the bottom half of the circle has got 4 pi over 3, 5 pi over 3, 6 pi over 3. We are not going in the positive direction. We're going in the negative. All right? So once around to here is -6 pi over 3. Another time around, -12 pi over 3. Another time around, -18 pi over 3. I got to get to -19. I'm here. Once here, I'm drawing an altitude, 90-degree altitude to the x-axis. We know 180 divided by 3 is 60 degrees. In class, I'm going to show you the ratios of a 60-degree. Because I'm in the fourth quadrant, well, I'm not really the fourth, I'm the negative, whatever. This is a positive 1/2. This is a negative √3/2, and the hypotenuse is always 1. So for the students I've already taught this to, cosine is 1/2, okay? If I haven't taught this, you might, I should have said it at the beginning, you might be better off not even listening to that right now, because it just might scare you, okay? So I want to build it up from scratch. And I guarantee you'll have success with this term. This year, everybody's going to do, okay? Okay, end of video. Let me shut this thing off. I'm tired. There we go. End for